Let's start with TelcoBridges operating software architecture. As you saw previously in TelcoBridges Unified Design, all of our products has two hardware components, the host and the telecom hardware. You might also have seen the term adapter in reference to the telecom hardware. This name comes from the early beginning of our product in the compact PCI world. Tctrl operating software is the application framework running on every TelcoBridges products. It consists of application running on the host and software running on the telecom hardware, also called the firmware or the adapter firmware. Now let's have an in-depth examination of Tctrl Applications' role. The light blue applications are the one allowing the user to perform OAMP, operation, administration, maintenance, and operation tasks. While the yellow, green, and orange applications are providing the core functionalities of TelcoBridges products. The web portal provides the graphical user interface to configure and operate our product. The configurations from the web portal are saved in a database. The OAM application is responsible for starting all the applications of the framework and make sure that every applications are running all the time. It provides the fault tolerance mechanism to restart a non-responsive application in case of a failure. It also sends configuration validation and activation commands to each application whenever it is needed to reload their configuration from the database. Finally, it orchestrates software upgrades in both standalone or 1+1 clusters. Now, let's introduce the core applications. First, the system manager, who's responsible to push the static configurations to the telecom hardware, such as TDM hardware trunk and signaling stack allocation. By static, we imply that the system manager is not involved for the processing of calls. It also manages the signaling stacks, high availability, and the system clock synchronization. Next, the gateway and the engine. Both are the core applications for processing calls. The engine communicates with the signaling stacks and provide a high level of call controls to the gateway application. The engine processes calls information, manages the telecom hardware resources needed during a call, and connects incoming and outgoing call legs. The gateway controls call flows and performs the routing logic using a Ruby script engine. It writes call detail records information, or CDRs, in text files and provide radius AAA authentication, authorization, and accounting. Finally, it provides a Megaco H248 interface to media gateway controllers. The TB router is the core application involved in SBC packet processing. It performs packet filtering, packet access control, and RTP relay. CallTrace gathers live call information from engine and gateway to provide high-level call flow analysis. For deeper analysis, TBSigTrace application can be used to live capture the low-level signaling messages in PCAP files or live display directly in Wireshark's open-source packet analyzer. SNMP provides alarm traps and allows polling of statistics and state of the system. Finally, LogTrace captures the low-level debugging information from the firmware running on the telecom hardware units. Tctrl operation software supports redundancy, running on two hosts, a primary and a secondary. The system manager, gateway, engine, TB router, and SNMP applications are working in active standby mode, with each application redundancy being managed individually. The next unit provides an interactive diagram with more details on each application.